Welcome back to Practical PyTorch. Last time you built the optimizer, the step that makes the loss smaller. Now you'll put the whole training loop together. 5 steps in one fixed order. Forward, loss, zero grad, backward, step. Every model you ever train runs on them. A model learns by repeating a few steps. The same steps in the same order over and over. Those steps are the training loop. Forward, loss, zero grad, backward, step. Learn them once. Every model you ever train runs on them. This video has 4 parts. First, the 5-step loop. Forward, loss, zero grad, backward, step. Second, we run it and watch the loss fall every epoch. Third, 2 words people mix up, epoch and iteration. And fourth, why zero grad is not optional. Skip it and the gradients pile up. Let's build the loop one step at a time. 5 boxes arranged as a ring. The loop starts with a forward pass. The model makes its guess for the current weights. The forward pass runs the model. Pred equals x times w plus b. That prediction is what we score next. Next comes the loss. It compares the guess to the target. The arrow shows the guess flowing into the score. This is the mean squared error loss from the loss lesson, one number that says how wrong the guess was. Third comes zero grad. Before we ask for new gradients, we clear the old ones. The arrow carries us on to the clearing step. Opt.zero grad clears the gradients. Skip it and they add up. That is the whole of part 4. Fourth is backward, the walk from the autograd lesson. One call walks the graph in reverse. The arrow leads into the backward step. Loss.backward runs autograd. It fills dub, u.grad and b.grad. That is the slope of the loss for each weight. Fifth is step, the optimizer step from the last lesson. It nudges each weight the way that lowers the loss. The last arrow reaches the step box. Opt.step applies W becomes W minus the learning rate times the gradient. One step downhill and the update is done. All 5 steps are on screen now, but the ring is still open. Now the return edge closes the ring. It runs from step back to forward. Back to the top with the updated weights and do it all again. The loop repeats once for every batch. That is one trip round the ring. Forward, loss, zero grad, backward, step. Then round again. You've seen all 5 steps. Now let's run them on a real fit and watch the loss fall. A tiny job. Learn the line y equals 2x plus 1. We build 8 points from that line. W and B are the 2 weights we will learn. We start them both at 0, so there is real work to do. SGD is the optimizer, handed the list of weights. No model class yet, just tensors, autograd, and SGD. The whole loop is wrapped in for over 6 epochs. Line 1 forward, the model makes its guess. Line 2 loss, score how wrong the guess was. Line 3 zero grad, clear the old gradients. Line 4 backward, fill in the gradients. Line 5 step, update the weights. Then we print the loss each epoch. 6 times round the ring, and that is the whole training program. Each epoch the loss drops. It falls from 2.7143 down to 0.0878. W is at 1.664 heading for 2. B is at 0.996. A few more epochs would finish it. A falling loss is the sign the loop works. Two words get mixed up all the time: epoch and iteration. Let's define them. Real data comes in batches, so one pass over the data is several steps. An iteration is one batch through the loop, one opt-dot step. An epoch is one full pass over all the data. 8 points in batches of 4 make 2 iterations per epoch. Now the same fit runs in batches of 4. Every epoch now has 2 iter lines, one per batch. The per batch loss is noisier. Look at iter 1. It jumps to 4.8807. Each batch sees only part of the data, so its loss bounces around. Training is still going fine. Remember zero grad, the step people forget. Let's see what breaks when it's gone. Take the working loop and delete opt.0grad. Everything else stays the same. There is no crash and no error, it just runs. So what breaks? Watch w.grad as the epochs go by. Without the reset, each backward adds to the last gradient. So w.grad piles up, first minus 1.714, then minus 2.988, then minus 3.493. The loss even turns back up at epoch 3. By epoch 4, it climbs to 1.7913. The piled up gradient makes the early steps too big. The loss overshoots and the fit never recovers. The fit ends wrong. W is 4.030, not 2. This is why the ring puts 0 grad before backward. Let's bring it together. The training loop is 5 lines. Forward loss, 0 grad, backward step. They run in that order every time. One trip round the ring is one step of training. An iteration is one batch. An epoch is one full pass over the data. And 0 grad is not optional. Skip it and the gradients pile up. Quick check before we go. You delete opt.0grad from the loop. What error do you get and what happens to training? Pause and predict. Here's the trap. There is no error at all. It runs. The gradients accumulate across epochs, so the steps grow too big. The loss overshoots and the fit ends wrong. W is 4.030, not 2. You now have the loop. You've seen every piece. The forward pass, the loss, 0 grad, backward, and the optimizer step. Next, we build a linear regression from scratch. Nothing but tensors and this loop. We watch the lines snap onto the data as the loss falls, epoch by epoch. See you there.